Okay, so how many minutes did she spend running on the 16th? 90 minutes. Good. So we subtracted from here, but if we wanted to be consistent, what would happen if we did this? Subtracted from, I'm sorry, one too many. And you'll see why I'm doing it this way in a second. What would happen if we did that? Could we do that? It's been 15 days, so 16 minus 1 is 15 days. So how would we figure it out using what we know here, subtracting from 1 from it? What would our starting amount be? 15, and then we would do what?
15 times 5.
Okay, 15 times 5. So what do we end up with?
90.
Did it work? Yeah, okay, 90 minutes. Okay, so let's try that again and make sure it works. So what did you find, how long did she spend on July 30th? 160 minutes. So let's see if that same pattern works again. From 30 to the 1st is what? 29 days. So if we do it like we just did the previous one, we're doing 15 plus what? Yeah, 5. In other words, times this 30 minus 1. Okay. Does that end up equaling 160? Did it work? Okay. Do you see why I kept going back to 1? What is the one amount that they gave me? Where she started, right? So this is going to be where she started. We call this A sub 1. So let's see if we can figure out any day if we can find a pattern. So for any day, what do we get? That would be like A sub n. What are we going to start with on all of these? How much she ran on day 1. So 15 plus, and then what did we do? 5 minutes times what? N is the day. But did we multiply by n? What do we multiply by? What is our pattern doing every time? Over on the side over there, we did
N minus 1.
minus 1, right? So it would be n minus 1, because we have to subtract out that first day, because, do you understand why we subtract out the first day? We already have it, don't we? So we want to know the number of days since the first day times that 5 minutes a day. So do you see how we can use what we see here based on what they gave us? So now let's generalize. Let's generalize to a general pattern. A sub n, this is A sub 1. This right here represents how much she's adding each day, isn't it? Yeah? That's what we call the common difference. This is D, or for common difference, okay? So in our formula, instead of 5, we're going to put what? D. Is the n minus 1 okay?
Yes.
Yeah. That's the number of the day we're looking for, minus the first day, because it's already accounted for. So now we have a general formula. Guys, this general formula is for what we call an arithmetic sequence. Do you remember these from algebra, in Algebra 2? This is the formula for the nth term. You know why it's arithmetic? Because we are adding each day. Okay? So what do you think? Now let's apply this. It says, what was Mallory's average run length during the month of July? So how do we figure out what her average run length was? She's increasing by the same amount every day, isn't she? So do we need to take all of it? Look, when we normally do average, we add everything up, don't we? But we don't have everything, do we? What do we really actually have? What are the things they actually gave me? They gave me the first and the last, didn't they? As a matter of fact, let's look at that. And let's see if that would work. What is 165 plus 15? I want you to notice something. I want you to notice a pattern here. If we add those two together, we get what? 180. What if we took 20 is the second day, and this is the second to last day? What is 20 plus 160? Oh, 180. Do you see something? If we take the last and the first, we get 180. If we take the next to the last and next to the first, we get 180. Do you think it's going to continue to do that all the way through? Well, let's double check. The next day in here would be 155, wouldn't it? And the next one here would be 25. So what would 25 and 155 be? 180. So if we keep pairing them up like this, we keep getting 180, don't we? So do you see that we could now, since we know that the ends in all end up equaling 180, can't we just take the average of the first and the last? Think about it. So how do we figure out what Mallory's average run length is? Yep, 15 plus 165 divided by 2. That's average, isn't it? So what would that be? That would be 180 divided by 2 is 90, which turns out is on the, isn't it the very middle? That's the middle day, isn't it? It's the only one that doesn't have an average with it. So the middle day, if it is an arithmetic sequence, that middle sequence number would be the average, or let's put this in terms of what we know. We took the first day, and we took the what? Last day, and we divided by 2. Every arithmetic sequence is going to act this way. It's kind of cool, isn't it? I love arithmetic sequences are neat little puzzles. So it says, how did you figure it out? What did we look at? We said the following. Her run time increased by what? A constant rate? Constant amount every day? What was that constant amount? 5, which is D, right? Constant amount D every day. So her average would be the middle day, which is day what?
16.
A sub 16, which is equal to 90. And then we found the pattern. So how many minutes total did she run for the entire month? Oh, we can use the pattern that we saw, can't we? Can we use the pattern that we saw? Remember what our pattern is? Do you want to have to find every single day? What did we notice? First day, last day, added up to what? 180. Second day, second to last day was 180. Third day, third to last day would be. So we can just figure out what that sum is and how many times that sum occurs, right? So we know on average she ran 90. Okay. So if on average she runs 90, how many averages would that per day, right? 90 minutes per day on average. How many days are there in July? So we know that average would be, we'd have to do 15 of those plus the middle day, or we could just say each average of those days, the first and the last. Are you getting it? The first and the last, average of those is 90. Second and the second to last, average of those is 90. 90, 90, 90, 90. Middle is 90. So how many days in July? Wouldn't that be easier? So we have 31 days in July. Times, how much did she run each day? On average. 90? So how much did she run for the entire month? So what was our strategy? N times the average, which is N times what? The average was what? A sub 1 plus A sub n divided by 2. We now have a formula. Look at this. We're getting good work done here. Did you know you could do so much with arithmetic sequences? All right. So let's look at the next one. Brother David also starts training on July 1st, keeps track of the number of miles he ran, but each day he only added 0.2 miles to his run. On July 18th, he ran for 7.6 miles. How many miles did he run on July 19th? That one should be easy. So to find on July 19th, what would our strategy be? To what? Okay. So we know July 18th. So on July 18th, he ran 7.6. And then he ran one more day of 0.2. So how far did he run? .8 miles. Can we use that same strategy to figure out how many miles he ran on July 22nd? This time, what are we going to multiply by? 3 or 4? I'm starting at 7.6, not 7.8. So I'm starting with the amount they gave me as the beginning. I'm not. Does that look like a point? I'm sorry, that's a mistake. It's times 1. 1 day at 0.2. Thank you for asking a question. I didn't realize that looked like a point. Alyssa said 4. 4 times 0.02? Why 4 times 0.02?
4 days away from the 18th.
Yeah, 4 days away from the 18th, isn't it? Okay. So we're coming up with a pattern again. Math is patterns. So how far did he run?
Probability of being found. You need some of these boys carry some stuff over there? Okay. All right, so this is what Florida was getting about.
How far did he run?
8.4.
Yeah. 8.4 miles? Uh-oh. How many miles does he run on July 15th? Can we work it the other direction? If we start with 7.6, what are we going to do this time? What times 0.02?
3.
Good. Yeah, I got this. You're so smart. So how far did he run? 7 miles. He is much less in shape than his sister. Write a rule that gives the number of miles David runs on the nth day of July. We're going to start at 7.6, right? Plus what? What's our common difference this time? 0.2. And we're going to do n, but are we going to do n minus 1 this time? Why not 1? It's not the original number we were given. What day were we given the original number for? So instead of n minus 1, we're going to do n minus 18. Do you see how this works for the positive and the negative? So if we're given day 15, 15 minus 18 is negative 3. It works. But if we're given the 19th, 19 minus 1 is, or 18 is 1. So this works either way. So are you seeing how to set up this type of formula? If it's arithmetic, what we started with plus the common difference times n minus whatever the beginning value was, right? If it's day 1, we start with a 1. If it's not a 1, we use whatever it is. Okay? Make sense? Yeah, pretty easy to follow. All right. Can we figure out now how many miles David ran on any given day without knowing how many miles he ran on July 1st? In other words, can we do an average? Could we? Can we figure out how many miles he ran on any given day without knowing how many miles he ran on July 1st? Well, didn't we just in the last previous step? Yeah. What did we say? Instead of subtracting 1, because we don't know 1, we subtract the number of the day we do know, don't we? So the answer is yes. As long as we know what?
Day.
Yeah. As long as we know the number of day the answer is yeah. We can add or subtract it from that run amount. The thing you have to be careful of for this class is when they ask you things like why or why not, you have to make sure you've written enough to really explain it. We're not used to writing in math nearly as much, are we? We just want to plug in numbers and run. Sometimes that's what y'all like about math. But remember, on this exam, they're going to ask you to sometimes to use your words. So you can't say yes and just point to that equation up there. You have to think about why it's yes. So how do we feel about this? Good? Okay. So let's quick note it. So here we go. Where's my camera on? I don't have my camera on. All right. So let's do quick notes for this. What are the things we learned? What is a sequence? What is an arithmetic sequence? First, let's start with the sequence. How do we define a sequence? It is what? Yeah, it's just a set of numbers, right, that are all what? They have commas between them. So it is really just a function. Official math definition here. A function whose inputs are positive integers. Now, what makes something an arithmetic sequence? No. What did we say? An arithmetic sequence has a common what? Common difference. In other words, you add the same amount or subtract the same amount to go from one term of the sequence to the next, don't you? Now, what is the explicit rule? What did we notice for the explicit rule? To go from one term to the next, to go from a sub n, to find any term that we want to, we take the first term and add what? Common difference times what? N minus what? Oh, you know where you look? Look right here. Which term are we using? So in this case, it would be n minus 1. If that were a sub 7, it would be n minus 7, wouldn't it? If it were 18, it would be n minus 18. Get it? So that tells me this, okay? So the nth term, so this is the nth term. This is the first term. Of course, you know D is the common difference. We also said we could do it what we call recursively, which means we could find it from the term right before it, couldn't we? So we could also say a sub n is equal to a sub n minus 1 plus d, right? Or a sub n is equal to a sub 0 plus d times what? Tell me how what that becomes. If we do a sub 0, it is d times what? N. Because it would be n minus 0, wouldn't it? What's n minus 0? So if we have the 0th term, we can just do plus d times n. Or if we really take this again, and remember we said any term, didn't we? So a sub n would be equal to a sub k plus d times n minus what? If this is term k, what are we subtracting here? K. So this is if we have, so the first one is if we have the first term. This is if we have the kth term, okay? If we have any term. As long as we have the kth term, we can still find it. So this guy is for the first term. This is for the kth term. This is explicit. This guy is called the recursive. You know why it's called recursive? Recurring. Recursive means one after another after another. If we want to find the next term, which we did, we just add that common difference, don't we? So if we have the first term and we want the second term, we just add d. If we have the second term and we want the third term, we just add d again, don't we? So there's explicit and recursive. All right. So let's see if we get this. Checking understanding. We have a sub 3 and a sub 6. Can we find the common difference? These are asking you to do things a little differently. So the first thing we need to know is what? How many spaces are between these two numbers? How many spaces are there? There are 3 spaces. Okay, so what is the amount from there to there?
Mm,
24. So we went forward 24. So can you tell me then how far we went forward each time? What would be the easiest way to do that? Divide what by what?
24.
So that's not something we specifically did, but do you see how it falls in here? So the common difference is 8. Now they gave us the 7th term is 18. The common difference is -5. Write a rule for the nth term. This is right there, isn't it? So are you going to use the first term explicit, or are you going to use the kth term explicit? Okay, so write it. You can do this. Did you get it? Do you see where each piece came from? This is the 7th term, isn't it? This is A sub 7. This is my D. And this is my 7th term, right? Whatever this is goes there. Okay. So let's look at the next chunk. The graph of this sequence is shown. Is this sequence arithmetic? Why or why not? If it's arithmetic, what should we be seeing? Each term changes by what? The same amount. These are my n's. So what is A sub 1? Let's write some of these down. What is A sub 1 here? What is this value? -6? Okay, this is A sub 2. What is it? -2. And let's look at A sub 3. What is it? So what am I doing each time? Oh, so I'm adding 4. I'm adding 4. Does that hold for all of them? Am I going up by 4 each time? Does that tell you whether or not it's arithmetic? Yes, it does. So is this guy arithmetic? And what's the y? There is a what? Common difference of, okay. Boom. Now write an expression for this guy. For the nth term. So what is A sub n? Can we use the first term one? So I'd use the first term version of this. So what is A sub 1? Plus what? Times what? Minus 1, right? Got it? Mario sets his cruise control at 68 miles per hour. Does this function represent, okay, is the function that represents his total distance driven after n hours an example of an arithmetic sequence? Why or why not? You said no or yes? I'm just asking. I didn't hear what you said.
I thought the second one was talking about the speed, not the distance. I didn't read this.
Mario set his cruise control to 68 miles per hour. Is the function that represents his total distance driven after n hours an example of an arithmetic sequence? Why or why not?
Yes, because it's the distance is like increasing at a constant rate because he's constantly going 68 miles per hour.
Okay. So it does it have a common difference after 1 hour? Here's the problem. We're not asking where he's, okay, total is distance driven for n hours. So after 1 hour, so if n equals 1, how far has he driven? 68. After 2 hours, how do we figure out how far he runs after 2 hours? So 68 plus another, so that's 1 more hour, okay? So n equals 3. $68 plus another 2 at 68. What is a sub? We're at a sub 0 this time, aren't we? What is a sub 0? Do we know? Well, I mean, 0, right? Boom. Because we don't know where he was at that point. This looks like it's arithmetic to me. Doesn't it to you? One hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours. Yep, looks like it to me. He's a set number of hours. Now, if his cruise control wasn't set, would it be? No. It has to be a constant difference, doesn't it? So the number of hours times 68 plus the original, right? So we got this. So yeah, okay, cool. Yay. Halfway done. Little Red's crumby day. Crummy day. I know it says crumby. I don't know why there's a B in crumb. Don't you love the English language? Why is there a B in crumb? Crumb. Should just be crumb. All right, so here we go. There are 15 tiles on the path from Little Red Riding Hood's house to her grandmother's house. On the first tile, Little Red drops 2 crumbs of bread. On the second tile, Little Red drops 6 crumbs of bread. You might ask why I'm reading it like this. Yeah. Doesn't it seem like it ought to be read like that? On the third tile, she drops 18 crumbs. On the fourth tile, 54, and so on. Describe the pattern and the number of crumbs she drops on each tile. So how can we do that? Tile 1. How about the number of the tile? Let's do this out. Tile number. And crumbs. Maybe we write it out this way, we'll see it. So tile number 1, how many crumbs did she have? 2. On tile number 2, how many crumbs did she drop? Tile number 3, and then tile number 4. Fill it out and then see if you can find the pattern for the number of crumbs. See, if you write it out that way, sometimes it makes it easier, doesn't it? 18, 54. Alyssa says she thinks she's found the pattern. The rest of you find the pattern? What's happening to the number of crumbs every time? Good. Do you all agree that what's happening every time is we're multiplying by? So on the 5th tile, how many crumbs does she drop? Okay. So what is the pattern? The number of crumbs does what? What do we call it when we multiply by 3? Ah. Triples from tile to tile, doesn't it? What are we noticing here? We're having, this is repeated what? Multiplication, good. All right, so look what we did in the next one. It says, complete the table shown the number of crumb drops in the first 6 tiles, using only 3s and 2s this time. Only using 3s and 2s. So the number of crumbs is what? 2, right? And then 6 can be written as what? 2 times 3. Why do you think I'm going to put that 2 first? Because it's what we started with, isn't it? And then how do I write 18? Okay, 2 times 3 times 3. And then the 4th tile, 2 times. You seeing a pattern here? I'm getting tired of writing 3s, guys. Is there an easier way we can do this?
3 squared.
Oh, okay, good. So this is 2 times 3 to the first. This is actually 2 times 3 to the 0, isn't it? What's anything to the 0 power? 1.
1.
So this would be 2 times 3 to the second. This would be 2 times 3 to the 2 times 3 to the fourth. This would be 2 times 3 to the fifth. Awesome. I'm seeing a pattern emerge, aren't you? Now we have to relate this. We already did number 3 up here, didn't we? Only 1 3 and only 1 2. Let's just put that right here. We'll say this is here, isn't it? How can we figure out how many crumbs she will drop on the 8th tile without continuing this pattern out? Using what we see in this last chunk. We know it's going to be 2 times 3 to something. So how do we figure out 3 to what power?
7.
Why to the 7th power? What pattern are you seeing here? Ah, here's the number of the tile, 4, but what is this? The number of the tile is 5, but this is a number of the tile is 6, but this is the exponent is a. So we're seeing that exponent be 1 less than the tile every time, aren't we? So 2 times 3, so this would be 1 less than the tile, so 8 minus 1. So 2 times 3 to the 7th, which is what?
4,000.
Yeah. I don't know how she keep it up with that. I guess she's like autistically inclined to numbers, isn't she? A savant? She's a crumb savant? Got to be something, don't you? All right, Little Red drops 1,062,882 crumbs on the 13th tile. How many will she drop on the 15th tile? How can we figure that out? We know she already started with this, right? We know from tile to tile we multiply by what? Okay, so how many tiles up are we going?
2.
Okay, so how many times are we going to have to multiply by 3?
1.
Twice, aren't we? So that would be times 3 to the what? Oh. So can we figure it out? You get it? We're going up by 3 times 3 and times 3 again. That's like times 9, isn't it? This is because the number of crumbs triples what? Twice? Okay. So how many crumbs does that end up being? A lot. More than she should be able to count. Did you get 9,565,938 crumbs? Okay. How many crumbs will she drop on the nth tile? So now we need to use this as our pattern. What is our, how many crumbs is she starting with? 2. What is our multiplier? And we are going to raise that to what? If we're at the nth tile, what did we find about the relationship between the tile and the exponent? -1. So if it's the nth tile, we're going to raise 3 to the what? n-1. Yes, you guys got this. 2 times 3 to the n-1. The 7th tile marks the halfway drop point to Grandma's house. How many crumbs does she drop on the 7th tile? Use your formula. What'd you get? $1,458 crumbs. All right, Kenny suggests multiplying the amount by 15 to determine the total number of crumbs dropped. Really? What did we say? On the 15th tile, how many crumbs are we already up to? 9 million something. If you take 1,458 and multiply it by 15, do that. Is that going to get us anywhere close to the total number of crumbs dropped? Why is this not going to work? So we know the answer is no. Why not? Is the change from tile to tile constant? We're not, constant means we're adding the same amount every time. This is not growing at a constant linear rate, is it? This thing is not going to look linear, is it? What's it going to look like? It's going to curve up and go up really fast, isn't it? It's going to look like an exponential. That's what an exponential looks like. It starts slow and goes up really fast, doesn't it? How fast it goes up is based on what we call that multiplier. It goes up 3 times fast. Every space, instead of going up by 1 every time, it's going to be tripled times 3. So that y is going from 1, up 3, up 9, up 27. You see how it's going to grow really fast? If it were going by 2s, it would go up 2, 4, 8, 16. So you see, it's not going at a constant rate, is it? So, because remember, a constant rate's going to be linear, isn't it? In other words, the change is growing. And that change, we need to come up with a formula from this. Let's find our formula from this guy. What does that 2 represent? Not n. That 2 represents a sub 1. That 3 represents our multiplier, doesn't it? We call that multiplier our common, not difference this time, common ratio. So times r to the, and that gives us our nth term. So this is our formula for this is not arithmetic this time. If it's being multiplied by a common ratio every time, this is the one we call geometric. So this is a geometric, this is the explicit. Geometric formula. And if you didn't quite know how to put this into words, you could on a test. Like if you got this question as an AP free response question and you weren't sure about this stuff, will his strategy work? You could always show that if you took this and multiplied it by 15, it's still way less than just that one term, right? And you could show, you could say this is less than even just one day's worth of, one tile's worth of terms. Clearly it is not going to work, right? So if you don't remember how to do it this way, be creative in thinking of some way to show that it's not going to work, okay? At least you get some of the points, correct? So let's quick note this and get to the last little chunk. Our quick notes for today, last little bit of them are, what is a geometric series or sequence? What's a geometric sequence, guys? It has a common what? Yeah. So arithmetic has a common difference. This has a common ratio. Do you know how to find the common ratio? If I give you two terms, can you figure out what the common ratio is? Yeah, we just divide, don't we? We use repeated, instead of repeated adding, we use repeated, multiplication. Or division, right? If we're going backwards, we could do division. One term to the next, right? Now, let's talk about R. If the common ratio is greater than 1, is this thing going to be growing or shrinking? In other words, if it's 2 or 3.5 or 5, is this thing going to be growing every time? Yeah. So it's going to increase. Terms are increasing. What if R is between 0 and 1? Like 1/2 or 2/3 or 3/5? Are the terms going to be growing or shrinking? Think about it. If R is 1/2, and I put 10 crumbs on the first tile, what am I putting on the next tile? 5, right? And then the next tile after that? 2.5. So if it's between 0 and 1, that means it's less than the whole amount every time, isn't it? So are the terms going to be increasing or decreasing? Decreasing. They're going to be shrinking, aren't they? Good. All right. Now, what are my explicit rules? For the nth term. A sub n equals what? What was my formula that I found? Yep, to the n minus 1. Or we could go a sub n equals a sub 0 times r to the what? If we take 1 back, remember our pattern. We do n minus 1 because we already have the first term. So if we don't have the first term, this is going to be r to the nth, isn't it? Does that make sense to everybody? We're backing it up by 1, so this is r to the n. Or what if we don't have the first term? What if we have some other term? R to the what? Yes. See? Y'all are getting this. R to the n minus k. If we start with the kth term, then we just subtract. It's just like with arithmetic, isn't it? Only instead of times, we're doing it as an exponent, aren't we? Okay. So it says write a formula for the sequence. 2, 10, 50, 20, 250. Write that formula, please. You can do it. You can, what's the first term? What are the things you need? The first term, the ratio, right? These are actually easier, I think. So find a sub 1 and find r and plug in. So what was a sub 1?
2.
What's r? Yeah, we're multiplying every time by 5. So what is my formula for a sub n going to be? Yeah. Seems easy enough, doesn't it? And once you know the formula, okay, so let's look at the next one. If a sub n is geometric, you have a sub 4 is 48 and a sub 7 is 384. Find the common ratio r and a sub 1. So we got to find the common ratio r. So let's do this as an a sub k, this guy. Let's use this guy and plug in what we know. We know this term, don't we? A sub 7. That is going to be equal to what? A sub k is which term? 4 times r, because we don't know r, do we? But do we know how many times we're multiplying by r? How can we figure that out? From 4 to what? This would be n minus k. So 7 minus 4, wouldn't it? You see where that comes from? This is my k. And this is my n, isn't it? So what is a sub 7? What is a sub 4? So can I solve that for r? How would I solve that for r? Okay, so solve it. Figure out what r is. What'd you figure out r was? Good. We get r cubed is equal to 8, right? So r is cube root of 8, which is 2. Now we have to find a sub 1. So which one of those would you like to use? Should we use this one right here? And now we're going to use this formula, aren't we? So we know a sub 4 has to be equal to a sub 1 times r, which is what this time?
2.
To the 4 minus 1 is not 6. It's 3. 2 to the third is not. So what is a sub 4? A sub 1 times 2 to the third power, which is what? 8. So can we figure out what a sub 1 is? Divide both sides by 8, so a sub 1 is what? Okay. It says find a sub, gives you a sub 1 and gives you a sub 2, and it says find a sub 3 if the sequence is arithmetic. So if the sequence is arithmetic, you have to find D and apply it, don't you? So how do I find D? If I have a sub 1 and a sub 2, how do I find D? Okay. So how much did it go up from 22 to 33? Okay, so we could subtract one term minus the next one, right? So now if I know D is 11, can I find a sub 3? How do I find a sub 3? Okay. Well, we know a sub 2, though. Wouldn't it be faster just do a sub 2? If we know a sub 2, what do we add to that? Ah, just the common difference, right? So what would it be? Would it have worked if we'd done it Alyssa's way? Done a sub 1 plus 2 times 11? Yeah. 6 of one, half dozen of the other. It works either way, doesn't it? What if it's geometric? How do we find the common ratio if it's geometric? Instead of subtracting, what do we need to do? Divide. Divide what by what? Yes. Divide 33 by 22. That leaves us with what? 3 over 2, which is, I'd prefer to deal with it as a decimal, wouldn't you? 1.5. Okay, so now how do we find a sub 3? Guys, what are we doing to each successive term? Multiplying by what? So we took 22, multiplied it by 1.5 to get 33. Now what are we going to do to get the next term? Multiply again, aren't we? So we're going to take 33 and multiply it by? Good. And what will we get? Okay. Last piece here of the puzzle. The first week of July was the opening week of the Deluxe Hotel. It had 200 guests that week. In the weeks immediately following, the bookings decreased by 5% each week. How many guests did the hotel have in the 3rd week, in the 11th week, etc.? This is a little trickier a question. What is our common ratio this time? Be careful. That's how much it decreased. But we're not asking for that. We're asking for how many guests do we still have, not how many we're losing. So what is our common ratio for what we are keeping? 5%. You see how you have to ask yourself what the question is actually asking you? If it was asking us how many guests we were losing each week, then the common ratio would be 5%. But since it's asking us how many guests we're keeping each week, it's 95%. So what does 95%, what's that going to be in a decimal? Okay, so how are we going to set this up? Write your formula for it. A sub n equals what? $200 times what? Now use that to figure out for the 3rd week and the 11th week. Oh, we already answered. Boom, we did that, didn't we? Sometimes it's easier to write the rule first and then answer the question. So figure it out. This is good, and I don't want to give you too much homework ever, because I think a lot of homework is, I think sometimes it's just busy work. But I think I would like to start doing some warm-ups to make sure that you're retaining what you are getting. I think next time we'll start with some warm-up problems on arithmetic and geometric sequences, and see if you can do this on your own. Don't forget that we do not have AHOP today. Pep rally, right? We gotta support our guy. Yes, please do.